Hi guys, my name is Karthik and I am from executeautomation.com and welcome to another video of our EA Weekend video series. And today we're going to talk about testing microservices with service virtualization using Mountebank. We have already discussed a lot about API testing with RestSharp and Rest Assured, basically like service very independently like an API and how to test them. But we have not tested the microservices as a whole and how we can do a service virtualization using a specific tool. And today we are going to talk about both the world testing microservices with service visualization in much greater detail. So before jumping into what is service visualization, let's first discuss about the microservices. Well, microservices is also known as the Microservice Architecture, is an architectural style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, owned by a small team, and the microservice architecture enables the rapid, frequent, and reliable delivery of large, complex applications. It also enables an organization to evolve its technology stack. So that's the whole purpose of microservices. Nowadays, a lot of companies are developing microservices, and if you just think about the Google's microservices or Netflix microservices or Spotify's microservice, just Google it and search about Spotify microservice and look for its images. You can see there will be like hundreds and hundreds of service running every day. And I'll be quickly showing you like how it looks like in our upcoming slides of this discussion. And yes, microservices are basically breaking down a whole monolith app into smaller services. That's how you should be understanding it. Well, while talking about these microservices with multiple services, testing them will kind of get very complex. We also discussed something about packed in our earlier videos in Execute Automation, such as contract testing tool. So packed is a contract testing tools, and contract testing is a way to ensure that the service, such as the API provider and the client, can communicate with each other. Without a contract testing, the only way to know the services can communicate is by using an expensive and brittle integration testing. We discussed about this packed a lot, and it is also available in my course, API Testing with RestSharp and Specflow course, in a complete detail, like how you can implement the consumer and the service and how you can provide the packed file and stuff. But yes, this is one way that you can maintain the contract between services in microservice based world, and you can see how the communication basically happens. So this is something called as a contract testing. And the contract testing is immediately applicable anywhere where you have two services that needs to communicate, such as an API client and a web frontend. Although a single client and a single service is a common use case, contract testing really shines in an environment with many services. But having well-formed contract test makes it easy for developers to avoid version hell, and contract testing is a killer app for microservice development and deployment. In general, a contract is between a consumer, for example, a client that wants to receive some data, and a provider, for example, an API on the server that provides the data to the client needs. So this is exactly what we discussed with what is called as contract testing, and we saw how contract testing can be achieved using the consumers and the provider fashion. But if you just see like how it can be achieved with the contract testing, like a robust contract testing to be applicable for any company with a given time frame, 100% contract testing becomes harder in microservice environment like Netflix, if you can see in here. If you have more than 50 plus services or 500 plus services communicating and are running in silos but require some feed between the services, then the contract testings become harder, even though you still need to implement that because it's very harder like how these services are communicating. As you can see in this left hand side of the diagram, you can see that there are so many services communicating each and every time for performing a certain action, which is very harder, and without contract testing or without a proper implementation of test design, it's going to be very harder. I don't even have to call what is called as a test design, because if you think about test design, the classical way of testing or the mindset of the classical way of testing is completely negated at this point. So the microservice architecture that we are going to be discussing is going to look something like this, as I shared an architectural diagram a couple of days before. As you can see, I have a machine which is going to run the Specflow and RestSharp client in a Visual Studio, and then it is gonna consume application which is gonna run either in a Docker-based environment, which is nothing but a microservice running in a Docker-based environment, or it can also be running in a Kubernetes service. But as of now, for this demonstration, I'm going to show you how it is going to run on a Docker-based environment, and also the service which is running within a bare metal service. So you can see that an application is going to be running either any one of these environments, or it can also run in combination of these two, or it can run in combination of these two and more than that on a cloud-based environment with more than 500 plus servers and stuff. So this is how the microservice is going to look like in a real-time environment. At least not exactly, but this is the replica of what I can show you as a demo of how the real-time microservice architecture is going to look like and how it actually works. If you consider a larger application, you can see that those applications may be running their services in a Kubernetes cluster or in a Docker-based environment which is running on your private cloud, or you may be running some of the services or consuming some of the services which may be running in a third-party system. So in these kind of microservice architecture based environment, testing them becomes very, very complex. And the most complex thing is how you can actually really have all these services talking each other without any problem. For instance, at this particular point of time, this particular number 1 and number 2 will work without any problem, because basically this is going to call an HTTP over the network, and then this network is going to call to one of our services which is running in this particular environment. But what if this particular microservice is going to call one more microservices, and those microservices is going to call thousands of other microservices to perform an operation? Then those kind of scenarios becomes very, very complex. And having all these services in place will be even more harder as well. So for instance, if this microservice is going to call another services, let's say service number 2, and this is going to call another service number 3, and there is going to be one more service which is completely independent, but this is going to be consumed by service number 2. And if you want to consume this particular service number 4 to be available for service number 2, and if you want to test this whole operation, you need to have all these services up and running for a complete test to happen. So instead of doing all these complete testing, it is also better that you can actually replace one of the service with a service virtualization, or nothing but mocking that particular service. So that's exactly what is called a service virtualization, guys. It's more like a mocking, but it is not exactly what the mocking does. So here you're going to perform a service virtualization, which is going to replicate pretty much like the actual service, which is nothing but the service number 4, but the expectation, the predicates, and the responses are going to be set by you, and see how the service is going to respond basically. So once you have this particular service virtualized, then this number 2 service is also going to work fine without any problem. And because service number 2 works fine without any problem, this service will also work fine, and then your test can execute without any problem. But at this point, you can see that the concept of what is called as an end-to-end test fades away, because you cannot really do a complete end-to-end testing, because you are actually doing a virtualization over here, making the test to be a little bit not realistic than compared to the actual realistic testing if the service 4 actually exists. But consider this, if you have 500 services, and if you want all these services to be available at any particular given point of time, then that's not going to be something happen in the test environment. You can expect that in production environment, but for the test environment, if you want to isolate the testing and see how every components are working, then it is always better to virtualize that particular service and see how the rest of the services are actually working. This is something like how you put a debugger breakpoint on a particular line of code and see how the code actually works, rather running the whole code and see what the expected output is going to be coming from that particular application, because that's going to be very, very harder, and you cannot really test and see how the application actually works. And that's exactly what we are doing over the microservice testing as well. We will be virtualizing few of the services, and we'll see how the rest of the components are working. And if the rest of the components are working fine, then the virtualized service alone can be tested separately, and then we can see how the rest of the components can be tested along with it. So that's exactly what we'll be doing here in the microservice testing architecture. Well, for our discussion, this particular component alone, we are going to be virtualized into what is called as a Mountebank server. So the Mountebank is like a virtual server which is going to replace this, and then it is going to have all the stubs, predicates, requests, and responses that the client actually expects, and then it's going to output you what exactly that you are looking for. So Mountebank, what is this? Well, Mountebank is the first open source tool to provide a cross-platform, multi-protocol test doubles over-the-wire testing tool. Simply point your applications under test to Mountebank instead of the real dependency and test like you would with traditional stub and mocks, whereas the Mountebank is the most capable open source service virtualization tool in existence at present in the market. Well, if you ask how this particular Mountebank is going to work, the Mountebank employs a legion of imposters to act as on-demand test doubles. So your test communicates to Mountebank over HTTP using the APIs to set up stubs, record and replay proxies, and verify mock expectations. In a typical use case, each test will start an imposter during test setup and stops an imposter during the test teardown, although you are welcome to configure Mountebank at the startup using a config file. So you can create your own config file which is going to have all the stubs and how the response of a stub is going to look like and how the predicate of the particular stub is going to look like and all those stuff. You can design that and you can put that in a config file, and then you can inject that config file for the Mountebank, but you can also code that and then you can see how it works. So Mountebank employs several types of imposters and each responds to a specific protocol. Typically your test will tell the imposter which port to bind and the imposter will open the corresponding socket. At first instance, if you see this particular how it works of Mountebank, it doesn't really make any sense because I'm talking something about the Mountebank, a new tool altogether, and I'm also talking about something called as imposters, stub, record and replay proxies, mock expectations, config files and stuff. But as you can see in the diagram in a very high level how it works, your test is going to call a Mountebank, and that Mountebank is going to magically create what is called as an imposters. And these imposter can either be consumed by your test to perform an action, or it can be also consumed by your application under test if that is going to be the case. For instance, if you're going to be mocking an test which is not going to have a particular service even being created by your company, you can just create an mock imposter for that, and your application can consume the mock imposter and run as the application thinks that is consuming something which is already exist in a real-time world. So here the imposters is the mock server which is going to run that, and everything is going to happen as it like an real world application, like a real application, but just that you need to set the expectations or the mock expectations of how the imposter should respond and what predicate it should expect for the application to consume. So this is how the whole stuff is going to work, but yeah, we are going to discuss about it in a very high level. So this time for this whole EA Weekend video series, I'm going to be using one of my course application code which I have already developed and I have already discussed a lot, and some of the basic discussions are also available in our YouTube channel on that, which is nothing but the RestSharp code. So that code actually runs in this manner. Currently our code in our RestSharp test runs like this. So you will have a RestSharp test which is going to consume an JSON-Server over HTTP, and then it runs the test. So instead of running over the JSON-Server as the application under test, we are going to set the expectation, create the stubs, and also create the response and the predicates using what is called as Mountebank, something like this. So you can see that we are going to replace the JSON server to Mountebank, and then we are going to do our testing. And the test which is going to run this particular Mountebank will not even know the difference between an JSON server versus the Mountebank, because to the test it always feels like it is really calling the HTTP call to perform the execution, and the test will run pretty much like how it works with an usual JSON server. So how the test setup needs to be done before the testing should be initiated. Let's see this in an actual test approach versus the Mountebank service virtualization approach. So basically in our current test, we have what is called as a JSON server. So we basically make sure that our JSON server is up and running. So we spin up the JSON server and then we run the test against the JSON server expecting the whole data that we are looking for is already available. If the data doesn't really exist, then the test will actually create the data in the JSON server, and once the testing is done, then it cleans up the data for the next run to happen without any problem. So this is how our current testing pattern happens with RestSharp using the actual JSON server, which is our application under test. Whereas with service visualization, because we are going to bring down this service visualization with Mountebank, we need to do a lot of setup in here. Something like this. We are going to initiate the Mountebank, which is more like an HTTP server, and we need to add the mock response to the stub. And then we need to add the mock predicates to call the stub, which are called as imposters. And then we need to run the test. And again, at this point, the test doesn't really know like if it is a mock data or not, because it is going to run the same HTTP call to perform an action and see how it actually works. And then we need to clean the imposters so that the server or the imposter can clean up the data and you don't really mess up with the port numbers and stuff. So all these things we need to be doing for this Mountebank with service visualization. So this is how the setup needs to be done for our testing in this particular point of time. Installation of the Mountebank is also much easier, and this is like a couple of commands to go with. The first one is you need to install the Mountebank using npm install-g Mountebank. And then you need to start the Mountebank using mb, but there are more commands where you can specify or inject a config file, or you can set the proxy to off and record and replay and stuff. So you can do all the sort of jazz there, but for the basic command, mb is more than enough for it. And the scenario for the test that we are going to be executing is going to look something like this. As you can see, it says that verify author of the post 1, something like this, and verify post 2 with the post 2, I'm expecting the author name to be Karthik KK, and I'm going to verify for the post 6 for the author name to be executeautomation. So you can see these are the data which I expect for a post of the post ID for the server to return to me. And in this particular point of time, with these scenarios, we are still going to use the imposters to perform an action for us instead of the real server to respond. So we need to set up all these data before we can actually do. So how we can create the step or the imposter for this particular kind of testing, it's going to look something like this. As you can see, I'm going to create a response object for the HTTP response field with a status code of HTTP status as OK, and the response object is going to be pretty much exactly like how an actual application responds with a model, which is nothing but the post model. And then I create the imposter by adding the stub, as you can see in here, and then I'm returning a JSON with the response object, this one, on the path of the method equals to /post/1. So if it is going to be a post of 1, this one, I'm going to return the response body as ID is equal to 1, title is Selenium test, and author as Karthik KK, so that our test will actually pass without any problem. So this is the one way of doing it, and there are many different ways of achieving this particular kind of imposters, but we'll be discussing a couple of them in our upcoming discussions. So we can also create a predicate, something like this. So in this particular demonstration, you saw that I have created a predicate on path and method equals to /post/1 of method name as get. But I can create a complex predicate, something like this, where I can mention the HTTP predicate field if the authorization of the request body is these, and it is going to be a post method. Only then you can respond with an access token of something like this. So this is another way of creating a predicate, and even more detailed way of creating a predicates and stuff. And again, predicates is mostly like a query parameter in Mountebank, and response is pretty much the HTTP response, and the imposters are actually the mock server data that you're actually creating on the step. So once these imposters are executed on the Mountebank, you can instantly see some of the responses coming to you. As you can see in the Mountebank server, once you initiate the Mountebank, it's gonna show you something like this as post/imposters. You can actually see the imposters running on the port number 2525 and see what are the imposters and stubs are actually running within your server. And once you run the test, it is gonna show you something like this. So as you can see, for the post one, it is gonna run on port number 8000, and then it is gonna respond to you. And once the execution is done, you're gonna delete the imposter for your next operation to happen. So this is exactly what I showed you on the earlier slide. So this is how you can achieve a service virtualization and testing the service virtualization using Mountebank. Let's see all the discussion that we had in much greater detail in a quick demo. All right. So before jumping into the actual microservice automation testing, let's first understand how my service is being designed. So I have already told you how the services are actually being designed and how it looks like in a real-time environment. In my current scenario, what I have is there are two servers which are running multiple services. There is one server which is running in my local machine on this particular server, which has an authentication and which has many different services basically. And these endpoints are being called only by an authentication to happen. So if you pass the bearer token authentication, you can only then grab that particular service or the endpoints and see how it actually works. Whereas there is another public profile service which is running in the Docker container, which is being deployed within my machine as well. But in reality, that is going to be something which is being deployed in Kubernetes cluster or Docker somewhere else in a local cloud or a private clouds and stuff. But at this particular piece of time for this demonstration, I actually have this Docker container running within my local machine, but that's actually running what is called as a public profile service. So the scenario that we are going to discuss is designed in such a way that our local server is going to access one of the service which is being provided by the Docker container, which is nothing but the public profile service. So if I want to see the post's information and who is the author of the particular post, and if you want to grab some of the information of the profile of the particular author, this particular server actually calls the public profile service and then it displays that to the user. That's how this particular server actually works. So there is basically an intercommunication between these two services, and they actually provide an actual service for the end user who is looking for that particular service. But what this scenario is going to do is basically we are going to mimic as if this particular service is currently not available most of the time, because this particular service is also being developed by another third-party company or something like that. And we need to ensure that our rest of the services are working fine without any problem, while we don't really have to rely on the public profile service. So now we are going to mock this particular public profile service using what is called as a Mountebank profile service. So once we mock this particular profile service using what is called as a service virtualization, then our rest of these services are going to work fine without any problem, while still we could able to see that our public profile service will also be working, just that the public profile service is going to be like a stub, which is nothing but a service virtualized stub, which is going to work pretty much exactly like how this particular server is actually looking for. So the current system which I'm talking about is going to have the services something like this. It's going to have a service such as post, location, and public profiles, comments, and file uploads. And the public profile alone will be running on the Docker container, and this is something internally being used by our bare metal server. And we need to replace this public profile service with a virtualized service so that we can make sure the rest of service and are working fine as expected. So the Specflow scenario is assuming that the public profile service is actually in place within our environment, and once we run this test, it is actually going to work without any problem, because as you can see, it has a JWT authentication and it's going to pass the email and password, and then it's going to call the service public profile, and then you're going to see that this particular profile is going to return as the information that we are looking for. But what if that particular service doesn't really exist and we need to virtualize that service? Then your Specflow scenario is going to look something like this. As you can see, we don't really require an authentication at this particular point of time because the service is being virtualized. I don't really need to authenticate as of now, but you can still virtualize the authentication process as well. But for this demonstration, I don't really have to, so I did not. But now, once I virtualize that particular service, the rest of the operation are going to work fine without any problem. So at this particular point of time, the test doesn't really know that whether the call which we are going to do is happening with a virtualized service or with a real service. So let's quickly discuss all these in the code and understand how things work. So for that, I'm going to flip to my Visual Studio IDE. Alright, so this is my Business Studio IDE, and this is the code which I have discussed in one of my course called API Testing with RestSharp and Specflow course, where I have discussed a lot of details on the file uploads, posts, locations, and some of the complex models where you can work for and things of that nature. But for this demonstration, you can see that once I run this particular test, they actually run on one of the server which is currently running all these services, which is nothing but this one. So you can see that the server is actually running and it serves all the request which is being requested by the test client. So once I run this, you can see that it actually starts running and it performs authentication for each and every operation, and then it generates the bearer token, and then the test actually executes and the test got passed over here. But the one of the most important thing that we need to be noticing in this time is the public profile, which is nothing but the get profile operation. So you can see that for this particular profile, if I see the code implementation, you can see that it actually calls what is called as a public profile service. So it changes the REST client base URL and it changes the service as well. Basically, all these tests which is running in my local server is running on the port number 3000, and the one which is running the public profile is running on the port number 90. I can quickly show you that in the Postman. So I can just go to what is called as localhost of 3000, and if I just show you the posts, it asks me for the authentication. So basically I really require an authorization header while I perform any operation. So I'm gonna go to the authentication bearer token, and there is this bearer token for me. And now if I try to send, you can see that I could see all the post information. And if I try to access what is called as a profile information like this, if I hit enter, you can see that it gives me an error like 404 not found, because this particular profile doesn't really exist. So if I try to access any other profile, it won't work as well. The reason being, this particular public profile is actually running in my Docker container. If I show you this particular terminal, you'll really understand what I really mean. So there is something called as a Docker image, which is created by me in my local machine, which is nothing but the JSON Docker server. And if I just show you this service, this one, which actually runs this particular service. So if I just show you the logs of this service, you can see that it actually runs my profile information over here. So since I have mapped this particular service to be accessed by the port number 90, I can just replace this to 90. And if I send this, you can see that I could able to see that post information. So this is what I'm actually looking for in my test. So if I just replace this to post of 1, you can see there is other informations coming in. So this is the service which is actually running our post information. Now, as I told you that this particular service is going to be taken down, and we are assuming that this particular microservice is not being developed or it's not yet ready. But still we need to test this, because our rest of hundreds of services that we have has to be tested without any problem to see that they are running without any problem. In order for that, I'm going to take down our service running in our Docker container. So I'm just going to do this Docker stop of this particular service. And then if I try to access this time, you can see that the server is not going to respond. The reason being, this particular server doesn't exist and the service will not be served at this point of time. And now at this stage, we are going to make use of what is called as a service virtualization. In order to use a service virtualization, we are going to get help from what is called as a Mountebank. So the Mountebank is already installed within my machine. I'm not going to show you how to really install and stuff. Rather, I'm just going to run the Mountebank service, and I will show you how you can access the Mountebank and you can see their imposters and stuff. So this is the localhost of the port number to access the Mountebank. And if I try to see how it looks like, you can see that it shows me all the imposters, config and logs. And if I go to the imposters and see what is there at this point of time, there is no imposters. So we need to really create the imposters, and we need to see how we can make a service virtualization pretty much like how we saw for the post profile. So in order for doing that, I'm going to go to my code over here, and then instead of this particular service which is being accessed from what is called as the local host of 90, which is the actual service, I'm going to replace this to a virtualized service. So I'm going to create a stub definition in here, something like this. And we don't really require any authentication at this point of time. So I'm going to just comment this code, and then I'm going to perform an implementation of this particular step definition, which is going to look something like this. So you can see that I'm going to be creating a simple predicate. I'm going to add a stub, and then I'm going to add on the path of the post of the profile of this particular path, which is going to be a get operation like how we did. And then it should be returning as these information like name and post ID and the profile ID and stuff. And once we submit this imposter, it is going to create the imposter pretty much like how you're going to get from the real-time service. And then we can access that particular imposter within our test over here. So I have already initialize the Mountebank service over here in my test initialize, where you can see that it has created an imposter which is running in port number 8000 this time. So if I want to call the mock service, for sure I should be using the 8000 port instead of the public profile service. So I need to replace that as well. So if you don't replace this one, your test is going to point to run on the public profile service, and it's going to miserably fail because that particular service currently really doesn't exist. And that's the reason we have created a stub in here. So now if I try to run this particular test, you should see that the test is going to pass without any problem because we have already located that to the port number 8000. So if you don't believe me, if I change this to 90 this time, and if I try to run this test, you can see that the REST API is going to call the port number 90, and it's going to see if that exists, and you can see that the test actually fails. So what has happened right now? You can see that the test actually initialized the Mountebank server, and it runs on the port number 8000, and it also created a stub, and then it is running that particular test on this particular port number, which is nothing but the 8000 for us. So if I go to the imposter this time, because it has created an imposter stub for us, and we have not cleared the imposter in our test, hopefully the imposter should be there. If I just hit send, you can see that I could able to see an imposter which is running on port number 8000, and if I hit send, you can see that this particular information or the stub information actually exists. So basically it tells me that this is the path of the profile where I'm actually going to return you this particular body information if you pass me exactly this particular path. If you pass some other path information, then it's not going to be basically going to work. So if I just change this to 8000, if I hit enter, you can see that I could able to see that. But if I change this to something like post information of 3, it's not going to return you anything, but it is going to return you a status score of 200. The reason being that particular response data doesn't really exist, and we have not even coded that stub. So this is what is called as the virtualization, guys. We have virtualized our service in such a way that we coded how the response should look like once we give this particular data. And now, since this particular Mountebank is a service which is running in this particular port number, you could able to actually use this one to be called within other microservices, which is going to be consumed and perform an action. So this is something which is also very, very important to see, that your test is not just going to create a mock data, but it's actually creating a virtualized service which can be accessed by other microservices to consume, and you can test those services as well. This is how the microservices can be tested, and you can leverage the power of microservices and see how it actually works. So now you have got an idea of how you can test bits and pieces of microservices in a much easier fashion. The last thing which I would really like to show you is the Mountebank itself. You can see that the Mountebank this time, it actually performs a get, and then it actually runs on the port number 8000. Now if I try to run this test, the test is miserably going to fail. The reason being this particular port number 8000 is being used by our test. So that's the reason you actually need to clear the port number or the imposter every time your test is being executed, which you can do something like this. So you need to delete the imposter. So I'm just going to call the Mountebank client, And once again guys, this code and how to create the Mountebank and all those details are going to be added to my course API testing with RestSharp and Specflow, where I will be discussing all these details in much greater fashion. But for this video, it has already dragged to close to 45 minutes, so I'm not going to show you how each and every lines of Mountebank has to be written. So you can see that the test has got successfully completed, but even if you run this particular test for the second time, this is going to run. The reason being, you can see that we're also deleting the imposter once the test is being executed. This is the power of service visualization, and this is how you can test each and every services and components of a big microservice architecture in much easier fashion. Hope you really like this video. Please put your comments and details below, like how you do your testing of microservices in your organization. If you feel there are other better way of doing it, please put your comments below. It'll be very helpful, not just for me, but also for the community who are going to read your comments. Once again, thank you very much for watching this video and have a great day.